We want to use the 68%, 95%, 99.7% rule to answer each of the following. So the random variable z is normally distributed with a mean of 0 and a standard deviation of 1. So we want to determine between -2 and 2. So that's, with a standard deviation of 1, that's plus or minus 2 standard deviations, and that means it's 95%, or a probability of 0.95. You could give that as a percentage. Z is greater than 1. Well, 1 is 1 standard deviation. Now we know that this is 50% because of symmetry, and this is half of 68%, so that's 34%. So together those are 84%, so this must be 16%, giving us a probability of 0.16. And then we have from -2 to 1. So if we look at this side here, that's going to be half of 95%, so that's 47.5%. This bit here is going to be half of 68%, so that's 34%. So we've got 47.5 add 34. So that's going to be 77.5 add 4 is 81.5. So that's 0.815. The heights of dwarfs in Middle Earth are normally distributed with a mean of 90 centimeters and a standard deviation of 5 centimeters. What percentage of dwarfs have heights greater than 95? So with a mean of 90, it's 95, and this is also 1 standard deviation because the standard deviation is 5. So very similar to before, this is 50%, this is 34%, so 84% down here, giving us 16% here, so it's 16%. Between 85 and 95, remember the mean was 90, so this is minus 1 standard deviation, this is plus 1 standard deviation, so that's absolutely standard 68%. Greater than 75. So if we put 75 here, that's 3 standard deviations. So we know that in between plus or minus 3 standard deviations is 99.7. That means that 0.3% is in the two ends, so 0.15% down here. Now we're after greater than, so that's going to be 99.85%. 100% take away the 0.15%. And then between 80 and 95, so 80, 90, 95, so this is 2 standard deviations, that's going to be half of 95. This is 1 standard deviation, so that's half of 68. So we've got to add those two together. I think we've done that actually before. There it is. So it's 81.5%.